Hi, I'm Josh Pugsley, and today I'll be giving you some information on the internals of a computer and how they relate to the overall user experience. First things first, the motherboard is the large, flat computer chip inside of the computer. It acts as the platform for all of the other components to talk to each other across. The choice of motherboard will directly correlate to the computer's capabilities, in that the expansion capabilities of the motherboard will dictate what RAM, processor, expansion cards, power supplies, number of drives, etc. the computer will support. The motherboard's processor socket will specify the brand, architecture, and version of processors that are supported. That then dictates the amount of RAM that is supported. Next we have the RAM. The random access memory, or RAM, is where the computer stores files that are used so constantly that conventional storage drives are too slow to be practical. Examples of this are page files, which are files that are used by the system to represent items such as environment variables, and items that are called on often, such as the computer's graphical user interface. RAM is a heavily utilized resource, and the more installed, the better the computer can perform activities such as browsing with many tabs open and quickly loading files. For most users, 6 gigs of RAM should be enough, but for users who plan on gaming, you may want to consider 8, 16, or even 32 gigs of RAM, depending on the games you're playing. And now on to the graphics card. The graphics card, whether onboard or add-on, is what powers the computer's video output and rendering. If a computer does not have an add-on graphics card, it is utilizing the processor's onboard graphics, which tend to be less powerful than the aforementioned add-on variety. If this is the case, then the computer's graphical performance may benefit from more system RAM, as it may be using this to preload video for applications such as hardware-intensive games or video playback. Alternately, add-on graphics cards have their own RAM built in, called Video RAM, or VRAM. As with the former, VRAM is used to buffer video for graphically intensive applications and to store files such as textures for use when gaming. If one was planning on playing games with their computer, they would benefit from an add-on graphics card, as they have a dedicated onboard processor and are optimized to render and output video. If one was planning on playing games with very detailed textures and objects, they would benefit from increased amounts of VRAM. However, if a computer is only being used to browse the internet and play videos, the onboard graphics should be sufficient. Possibly the most important part of the system, the processor is like the computer's brain and nervous system. It computes the information delivered to it in the form of bytes and then routes that information to the intended source. PC processors are mainly made by two vendors, AMD and Intel, and are further differentiated by their respective architectures, meaning versions and models. A3, i5, Atom, etc. What all of this translates to is that processors come in different types for different use cases. For an example, an i7 from Intel would outperform an Intel Atom, but the Atom will have superior power efficiency. This will then affect the user's experience accordingly based on what processor they're using for which job. Processors that have multiple cores that are thus hyper-threaded will be better at applications that perform multiple tasks at once, such as Adobe Premiere, assuming said applications are properly optimized for the processor in question. Due to it being the hub of most of the computer's moving data, a processor that is insufficient for the task it is carrying out will bottleneck the rest of the system, meaning that, for example, regardless of how much RAM is in a system, if the processor isn't up to par in carrying out a task, it will cap the RAM's performance because it cannot transmit the data to the memory as quickly as said memory is capable of receiving it. In situations where a processor is under a constant load, such as rendering large amounts of high-quality video, a powerful processor, such as an Intel Core i7-4770, will be useful, whereas in an environment where large amounts of data is being read and written often, such as a server, something like a Xeon would be more appropriate. Whereas in a small but capable laptop, something like an AMD APU would be perfect. So, to sum up what has been a large segment, to get the best value, not only monetarily, but also in efficiency, heat output, and physical size, the user must decide what their use case is for said processor, and that will dictate which processor is right for them. But what good are all these components without power? Well, that's where this device comes in. The power supply, or PSU, is the device that receives power from the grid, then converts it into a form that's usable by the system. As a general rule, the more powerful a computer is, the more power it will require to power it, thus necessitating a higher wattage power supply. The main factors to take into account when choosing a power supply, after one is sure that said power supply can power the respective hardware, are reliability and efficiency. The power supply delivers energy to the entire system, so reliability is key. If a problem occurs in this component, it could be potentially disastrous in that it could destroy all of the components in the computer. For this reason, it is always best to choose a PSU from a reputable vendor rather than save some money and buy a cheap one. As for efficiency, the higher in the system, the more power it will pull from the wall. Therefore, the higher efficiency, the more money will be saved. This is sorted by the PSU in question's 80+ rating. Whereas a low-end system will be fine with an 80+ bronze or silver power supply, a high-end system will benefit from an 80+ gold, platinum, or titanium power supply, the efficiency of which increases chronologically. Last but not least, we have the storage drives. The hard drive, or solid-state drive, is the storage of the computer. Most files are saved here, as it typically has far more capacity than any other device in the computer. Most computers use hard drives, devices that physically write data to an internal platter, aka disk, using a magnet. This is adequate for most use cases, and is far cheaper per gigabyte of storage than its solid-state counterpart. Solid-state drives, although more expensive than hard drives, are much faster. These drives also have the added benefit of durability. Since there are no moving parts within an SSD, they can be put through far more abuse than a traditional hard drive, which is a delicate piece of hardware. For a casual user, a hard drive should be sufficient, whereas for a power user or gamer, using a small SSD as a boot drive and a hard drive for mass storage, or even a purely SSD-based system, will be more appropriate due to the SSD's prowess when it comes to loading times. So there you have it, the basics of a computer and how the components translate to their respective user experience. Though some components may be added or removed from computers, these ones will remain for the most part the same. I hope you found this video enlightening and entertaining. Josh out.